Okay, so we're going to continue by going over the column on the right here. We'll start with the argument, if Dana is a sister, then Dana is a sibling. Dana is a sibling, therefore Dana is a sister. So I want you to think through this for a second to decide whether you think it's valid or invalid. It's always good to try and figure these things out. In fact, this argument is invalid. So once again, to see that it's invalid, we can imagine Dana Carvey, who is a male. It's true of Dana Carvey that if Dana is a sister, then Dana is a sibling because it's true of everything. As I said last time, it's true of the soccer ball on my desk. That if Dana is a sister, then Dana is a sibling because it's just definitional of sister that you are a sibling. So if Dana Carvey is a sibling, then Dana is a sister, then Dana is a sibling. Dana is a sibling. We'll just say it's true of Dana Carvey that Dana has siblings. Therefore, Dana is a sister. Well, it's not true of Dana Carvey that Dana is a sister because Dana Carvey is male. So in that case, we would have a true premise, true of Dana Carvey because it's true of everything. A true premise here, Dana is a sibling, true of Dana Carvey because Dana Carvey happens to have siblings. And it follows that Dana is a sister? No, it doesn't. So the argument is invalid. Again, in the video coming momentarily, we will talk about exactly why these are invalid, and I'll give you illustrations to distinguish the valid from the invalid in intuitive ways. Right now, I want you to be kind of relying on your own intuitions, and I'll give you some first-pass explanation, but not much more than that. Next one. If Obama is president, then Obama won the election. Obama won the election, therefore Obama is president. Well, that's once again invalid. It says if Obama is president, then Obama must have won the election. Obama won the election, therefore Obama is president. Well, not necessarily, because this doesn't say if you win the election, then you're president, right? It doesn't say if you win the election, then you're president. Just like the rule we looked at earlier in the semester didn't say if you're an even number, then you're a vowel. It only said if you're a vowel on one side, then you have an even number on the other side, right? It didn't say if even number on one side, then vowel on the other side. It only goes in one direction. Just like if you're a sister, then you're a sibling, doesn't imply if you're a sibling, then you're a sister. So if you're president, then you won the election, doesn't imply if you won the election, then you're president. But the argument acts as if it does, because once it establishes that you won the election, it says you're president. So it acts as if you can go from here over to here, but the first premise doesn't say that. Here's another example. This is from a few years ago. I'm thinking of Chris Christie, the then governor of New Jersey. If Christie knew about the bridge shutdown, then he should go to prison. Christie should go to prison, therefore Christie knew about the bridge shutdown. Well, I think it's true if he knew about the bridge shutdown, then he should go to prison. This was a case where a bridge was shut down for sort of political reasons rather than ordinary construction type reasons. And as a result of the bridge being shut down and consequent traffic, there was a death of someone in an ambulance who couldn't get across the bridge. And it was clearly shut down for political reasons. The question is just, did Chris Christie know that that was going to happen? You might say, well, look, if he knew about it, then he should go to prison. That seems clear. And then you might say he should go to prison, therefore he knew about it. But that doesn't follow, right? Because there may be other reasons why he should go to prison. Not because he knew about this bridge shutdown, but for other reasons. So again, it's possible for these premises to both be true and yet this conclusion false, which means the argument's invalid. How about this one? If Assange, this is Julian Assange here, assaulted someone, then he should go to prison. Julian Assange was accused of assaulting someone in Sweden, I believe. He should go to prison, therefore Assange assaulted someone. Well, it doesn't follow. Yes, if he assaulted someone, then he should go to prison. And you might say, yeah, and I think he should go to prison, although for totally different reasons. Not because he assaulted someone, but rather because, he shouldn't have published that stuff on WikiLeaks or whatever you think it might be. Okay, so here again, we have an argument form that's invalid. Okay. Sorry, I was just looking away. My dog was shaking something, and I didn't know if it was something she should have, but it's okay. Okay, so let's proceed. Over here now, if Jane is a sister, then Jane is a sibling. Jane is not a sibling, therefore Jane is not a sister. This argument form is valid. People often have trouble with this one, so I want you to really think this through. Again, I'll give a more detailed explanation later, but right now I'm just going to go like this. Look, the first one says being a sister is sufficient for being a sibling, meaning if you're a sister, then you just have to be a sibling. If you're a sister, then you're automatically a sibling. Which means if we learn that you're not a sibling, it means you couldn't have been a sister, because had you been a sister, you would have been a sibling. So since you're not a sibling, you couldn't have been a sister. Okay? So the argument has the form if P, then Q, but Q is wrong. So P must be wrong. Why? Because P guarantees Q, but you didn't have Q. So you couldn't have had P, because if you'd had P, you would have gotten Q. So again, the argument is valid. That is, it's impossible for these to be true, and yet this false. Now we continue on. The next argument has the same form. If Obama is president, then he won the election. He didn't win the election, therefore he's not president. It's saying if P, then Q. So P guarantees Q, but we didn't have Q. Well, had we had P, we would have definitely had Q, but we didn't have Q, which means we couldn't have had P, because if we'd had P, we would have gotten Q. So once again, the argument is valid. And I'm going to let you look through the rest of these on this side here and think about them and realize that they're valid because they have the same form as these other ones, which are valid. Okay, what about the next one? Either you can think clearly or your thinking will mislead you. Your thinking won't mislead you, therefore you can think clearly. That's once again valid. To see why, notice it says either this condition obtains, you can think clearly, or this condition obtains, your thinking will mislead you. So one of those two, you think clearly. At least one of those two, you think clearly and your thinking will mislead you, must be right. The next premise just says, well, one of them is not right. This one here is not right, which means you're stuck with the other one. You could think clearly, and that's what the conclusion is. So this has the form either P is true or Q is true, but Q is not true. Therefore, P must be true, because either P is Q or true, Q is true. You can think of it like you're crossing out the second one and you're stuck with the first. Notice it can work in the other direction. Had this premise here been, your thinking clearly will not mislead you. Had this premise here been, you're not thinking clearly, then we would have been stuck with the other one. Your thinking will mislead you, which would have then been the conclusion. So it has the form P or Q, and then the second premise crosses out either one. Whichever one it crosses out, you're then stuck with the other. If it crosses out Q, you're stuck with P. If it crosses out P, you're stuck with Q. Okay. And the rest of the arguments will have the same form. Either elves can swim or brownies are pixies, but elves can't swim, therefore brownies are pixies. So this says either P or Q, and then we learn one of them is wrong. P is wrong in this case, therefore Q must be right. So that's once again valid. And once again, I'm going to let you kind of look through these on your own and think through them. Just notice they all have the same form. So if one's valid, all are. If one's invalid, then all are. Now, finally, this last column here. Well, there's an ambiguity in natural language when it comes to the word or. This word right here, or, is ambiguous in natural language. And what I want you to see here is, in order to determine the validity or invalidity of this kind of argument, we need to disambiguate. We need to figure out which way we go with that ambiguity. So what's the ambiguity? Well, if I say P or Q, I could mean either P is true or Q is true, but not both of them. So I could mean at most one of them is true, and at least one of them is true. Or I could just mean either P is true or Q is true, and maybe both are true. So I could mean at least one is true, but not add at most one is true. So suppose I mean here at least one is true. So ducks are animals or deer are animals. Ducks are animals, therefore deer are not animals. Well, then that's invalid. Why? Because or on that reading allows or both. So it's saying, well, either ducks are animals or deer are animals means at least one of those is right. But maybe both are right. It doesn't preclude the possibility that both are right. It's as if I said, I'm going to go to the store and I'll definitely get bread or a baguette. And then I come home with both bread and a baguette. You can't say, liar, you said you were only going to get one. I could say, no, I meant I'll get at least one of them, but I could get both too, that's fine. That's a perfectly normal use of the word or. Here's a very different use of the word or. I say you're either going to get a C in this class or get a D in this class. I don't mean or you'll get both, right? You're just going to get one or the other. If you got one, you didn't get the other. So sometimes or means at most one, and sometimes or means at least one. And when we use or in logic, just by stipulation, natural language has both meanings, but we use the or symbol in logic to mean at least one. So it always means P or Q or both P and Q. So it allows that both are true, which means all of these arguments are invalid because all of these arguments are assuming the or meant at most. Now, again, that's a perfectly legitimate assumption, right? In natural language, it can go either way, so you kind of have to figure out what the speaker intends. I'm just pointing out that for the purposes of representing argumentation in logic, we just treat the or, when we do the symbol, as meaning at least one is true, maybe both are. If you want to say at most one is true, I'll show you how to do that later, but what you would say is this. You would say P or Q and not both P and Q. So then you'd be saying at least one is true and they can't both be true. That's what you'd have to write if you wanted to say at most. You can't just do it simply. Whereas because we're stipulating that the or means maybe both, then we can say P or Q and maybe both by saying just P or Q. But, saying nothing more than that. Okay, so this last column, as I said, it's ambiguous. You have to do this disambiguation to figure it out. Okay, so that's this exercise here explained. Hopefully it's clear. If you have questions, you can ask them during my office hours. We'll stop this exercise there.